Short lesson today. Look at that. 2 slides over here. That's not too bad. It's in section 2.6. 2.6 is officially titled Proof Statements About Segments and Angles. We're going to be looking at proofs, 2-column proofs, theorems, and we are going to be constructing a 2-column proof to prove a statement about either segments or angles. So a proof is defined as a logical argument that shows that a statement is true. We are trying to prove something to show that a statement's true. We're going to look at a way to make a logical argument to show that by forming a 2-column proof. So a 2-column proof has statements, they're numbered, so they go in order, as well as the corresponding reason that show an argument in a logical order. So 2-column proofs, we'll be using them quite a bit in geometry. We'll have numbered statements and their corresponding reasons that show an argument in a logical order. So it kind of is a step-by-step walkthrough on why a statement can be proven to be true. We've defined a conjecture. A conjecture is something that we are guessing to be true. Remember, a postulate is something we understand to be true, but we don't necessarily show why it's true. A theorem is something that can be proven to be true. Something we can prove, something we can walk somebody through step by step and show why it's true is called a theorem. You've heard that phrase before, the Pythagorean theorem, amongst others. A squared plus b squared equals c squared. The sum of the square of the legs of a right triangle are equal to the square of its hypotenuse. There's a way to walk through step by step on why that's true. It's called a theorem. So our one and only example asks us to create a 2-column proof, and we want to prove that angle BEC, this angle right in here, is congruent to angle AED. AED is this one down here. So we're trying to prove that angle BEC and AED are congruent. 2-column proof, we're going to make a list of statements as well as give their corresponding reasons. So we want to show these are true. Notice this angle here. I can also think about, okay, this entire angle, which uses AEB as well. And notice that's a linear pair, right? Let's start there. Angle BEC and angle BEA form a linear pair. Reasons, a lot of times it's when I say given, that it's given as a statement. I'm going to state my reason as shown in the diagram. we can see in the diagram that that's true. And we're also looking for something about AED. AED is this angle here. And we should probably maybe try to use this same angle over here, the one we used on the previous one. So notice that right there is also a linear pair, right? So my second statement, I'm going to state angle, we want AED, and I'm going to list it in the same order that it's given up here. AED and angle, this angle right here, which is AEB, but again, I'm going to list it in the same order that I've already stated previously, BEA. Those are also a linear pair. And again, that's shown in the diagram. We can see that based on what they gave us in the diagram. Now, a lot of times we want to use kind of what we stated in these first two statements and go from there. So if they form a linear pair, what do we know? Well, a linear pair we know is supplementary. So the measure of angle BEC plus the measure of angle BEA equals 180 degrees. In this same step, you can do it in the same or separate steps, but I also know the measure of angle AED plus the measure of angle BEA is also 180 degrees. And you could have done these two in one statement if you wanted. This is, well, we said those were a linear pair, and that's why they add up to 180. That's the definition of a linear pair. A linear pair, we said when we defined it, it has an adjacent side, or they are adjacent angles, so they share one ray, and they add up to 180 degrees. They form a straight line. Now, remember, I'm trying to show that BEC and AED, BEC and AED are congruent. We show that by showing that their angles measure the same thing. So BEC and AED, I want to show that those are the same thing. They're equal to each other. Well, I've got 180 and I've got BEA in both these, right? So I'm going to subtract this over to the side for each of those. This is going to be statement 4 for me. I'm going to say the measure of angle BEC is equal to 180 minus the measure of angle BEA. And the measure of angle AED is equal to 180 minus the measure of angle BEA. So I subtracted the measure of this angle over to each side. Think about what that is. That's the subtraction property of equality. We talked about that property last lesson. And now we should recognize that 180 minus the angle of BEA is in both of these. So I can say the measure of angle BEC is equal to 180 minus the measure of angle BEA. But I can substitute this in for 180 minus the measure of angle BEA because these are equal to each other. This is the substitution property of equality. Yes, we were trying to show that these angles are equal to each other in measure. Really, what we're trying to prove, though, is that the angles are congruent. That should be our final thing. Our final statement should be that the angles are congruent. And that's not quite what this says. Our final statement is that the angle BEC is congruent to angle AED. And for a reason, we would state, well, that's what congruent angles are, right? If their measures are equal to each other, we know they're congruent. This is the definition of congruent angles. My pen's acting weird. I don't know what's going on with my pen. I'm trying to write it with my mouse. Definition of congruent angles. That's really difficult to do. Very sloppily written, but you see what I'm trying to get across there. So due to the definition of congruent angles, we know if their angle measures are equal to each other, then they are congruent.